The Marbleslides activity in Desmos that you're going to be doing today is designed to help you review the most basic of rational functions. We start out with the parent function 1 over x, and you notice that it has two asymptotes. A vertical asymptote at the y-axis, which is when x equals 0, because we can't divide by 0, therefore a vertical asymptote. A vertical asymptote indicates an undefined number at that x value. Then we have a horizontal asymptote at y equals 0, because when x gets really, really big, y gets close to 0. Now, we can adjust the position of those asymptotes by adding a number, either adding or subtracting a number either in the numerator or outside the function entirely. So, for example, if I add plus 2, it shifts the whole graph up 2, so my new horizontal asymptote is at 2 instead of at 0. If I add 2 in the denominator, then it shifts the whole graph to the left, making the new vertical asymptote negative 2, because now negative 2 substituted for x makes the denominator 0, and therefore x equals negative 2 results in an undefined value for y. Of course, we could do both together. So there's an example. So now we have a horizontal asymptote. So if I were to put in just y equals 1 here, there's our horizontal asymptote, and our vertical asymptote x equals negative 2. Yep. So those are where the asymptotes are now. Now, once we have our asymptotes in place, I'm going to go ahead and make these dotted in black, so they're just kind of both sort of not the feature here. So those are our asymptotes, all right? So if we go back and look at our equation, now what happens if we change the numerator and make it larger? So if I make it 2, for example, notice now, instead of going over 1 and up 1, we're going over 1 and up 2. In other words, it's stretching the graph farther away from where those asymptotes intersect. So there's 3, 4, etc. Okay? Now the other thing, I'm going to go back and make this 1 again. The other change we could make is to make that numerator negative, or that would be, or the whole function negative. So if I made the numerator negative, notice now the graph shifts from being in the should we say like the first and third quadrant of these asymptotes. It's not really the first and third quadrant of the whole graph, but the positive upper right and lower left side quadrants to the upper left and lower right. Okay, so it flips the graph vertically over the horizontal asymptote. We could also put that negative sign in front of the entire function, and it would do the same thing. So those are the features of the graph that you'll be manipulating to do the Marbleslides. One other thing I want to show you is that you can limit how much of the graph shows by limiting either the x or the y, the domain or the range. So if we, in curly brackets, we can put in, for example, x is less than 3, and it will only show the part of the graph where x is less than 3. We could put another number on the other side, say negative 1 is less than x is less than 3, and it will only show the graph, part of the graph in between negative 1 and 3.